Today we are going to do Chapter 5, Lesson 5. This is called Simplify Algebraic Expressions. You really want to pay attention to the notes and the vocabulary that we talk about today because we are going to play a game to practice what you learned tomorrow in class. So, first thing, here are your notes. Like terms, this is going to be a big focal point of the chapter. Like terms are terms that have the exact same variable parts. We need them to be exactly the same in the variable part of the term. Think about them having like the same last name. Number 2, we can only add or subtract terms if they are like terms. If they're not like terms, we can't add them together. We cannot subtract them from each other. That is only saved for terms that have the same variable parts. Number 3, we're talking about a term here called a constant. So let's fill in the note first, then we'll talk about what a constant is. It says all constants are like terms. Okay, fill in those notes with the bolded words. And then I want to talk to you about constants. Constant is a vocab word this chapter. I want you to make space to write this note on your paper, and that is that constants are numeric terms with no variables. So pretty much a constant just looks like a regular old number, but when they are in an algebraic expression, we give them a special name. We call them a constant. Okay, so my examples for you are 3, 8, or 15. They can look like any of these, just no variable. Okay, let's talk about like terms. Like terms, if we are talking about this term in the middle here, 5x, remember what I said about like terms. They have the exact same variable parts. So I'm going to give you about 3-4 seconds to look at the other terms we have out here. And I want you to determine which of those are like terms with 5x. Okay, you've had a little bit of think time here. Let's go through them. The ones that are most obvious right here, 1/2 x. It's a term that has the same variable part, the x at the end. This guy here, -x, another pretty clear example. We've got the exact same variable piece, the x. And this term here, 12x, we have the same variable part, okay? So those 3 are pretty clearly like terms with 5x. The other 2 we have to talk about. So if we look over here at this term, 3x squared. X squared means x times x. So if we think about what that term would look like if we kind of expanded it, it would be 3 times x times x. So that's not the same as 5x, different variable part. So they are not like terms. Over here, we've got this guy, 8xy. We have the same x going on here, but that y throws things out for us. They are not like terms because this has an 8, an x, and then a y at the end. That means 8 times x times y. Not like terms with this guy here because this is just 5x. So these guys are not like terms. Please be really careful to think about like terms having that exact same last name, that exact same variable part. Let's go to some example problems. This is 1A from your note packet. It says in the directions that it wants us to identify the terms, the like terms, the constants, the coefficients, and then simplify the expression. So, we see a new word show up here, coefficient. We're going to talk about that in just a second. Let's start with the terms. Easiest way to identify the terms is to look for the plus and minus signs. The plus and minus signs will separate the terms for you. Okay, so our first term is -15m. Our second term is +12p. Our third term is +3m. Our fourth term is -4p. Yes, I said negative. We're going to kind of shushle that sign over there with the term. And our final term is +17. So if we are asked to write out the terms, here's what you're going to do. We're going to write each of those terms, and we are going to separate them with commas. So the first term is -15m, second term 12p, third term 3m, fourth term -4p, and the fifth term is 17. Next, we are asked to find the like terms. Like terms are going to be the terms that have that same variable part. So we're going to start with the negative 15m. And the term that is like negative 15m is the positive 3m. There's our first set of like terms. Second set of like terms, now we have positive 12p and our negative 4p. Don't forget the negative sign there. Those are the only sets of like terms that we have. Next, it asks for the constants. In this problem, constants are going to be the terms that do not have any variables in them. So if we look at our first term, negative 15m, that has a variable in it. This guy has a variable p, variable m, variable p. The 17 is the only term that does not have a variable, so that is our only constant. New word is coefficient. Prefix here is co, and I want you to take a look at that prefix, co. Co means that we are working together, okay? So the coefficient is going to be the number that works with a variable. So what that means is it's the number in front of a variable in a variable term. So our first coefficient is negative 15. That's the number in front of the m. Our second coefficient is 12. That's the number in front of the p. Our third coefficient is 3. Our fourth coefficient is negative 4. 17 is not a coefficient because it's not working together with a variable. That one's called a constant. Review those vocab words very heavily tonight. Make sure you know what they are for tomorrow, okay? Coefficient works together with a variable. Co means to work together. So those are our coefficients. Last thing we are asked to do is to simplify the expression. To simplify this expression, the first thing I want to do is I want to pick out those like terms. So my first like term is negative 15m, and it is like positive 3m. I'm going to put boxes around them, okay? Next, I'm going to circle the next set of like terms, positive 12p, negative 4p. And then my last term is a constant. It does not have any like terms, but I can put a symbol around it if I want, okay? Take notice to the fact that when I wrote my symbols, my shapes, to kind of pick out my like terms, I included the sign in front of the term. That's going to be a big helper here for us in our next step. So the next step is to take these terms and to regroup them. We're going to use our commutative property to rewrite this problem in an order that puts our like terms together. So we are going to start with negative 15m, and we're going to put its like term next to it. So that's plus 3m. No more like terms, but I have to keep going because I'm rewriting the entire expression. So now I'm going to add, I'm going to do a plus 12p. That's my next set of terms here. Plus 12p minus 4p. And the last term is my plus 17. So all I've done in this step to simplify this expression is to take my circles and my boxes and regroup my like terms together. That's called the commutative property. I'm just reordering the problem. I can do that as long as I take the sign with the term. So my first little problem here that I have to simplify is negative 15m plus 3m. 15 negatives, 3 positives, that gets me negative 12, and I can't forget the m at the end. Next problem is positive 12p minus 4p. I've got 12 p's, I take away 4 p's, that gets me a positive 8p. So I put my plus sign here because it's positive 8p. Last but not least, I have my lonely constant. There is no like term there, so I just bring it down into my problem. If I try to simplify this expression any further, you'll see that I can't do it. I don't have any like terms. So no like terms means that I can't add or subtract anything else. This is as simplified as it gets. So my final answer is negative 12m plus 8p plus 17. I want to just remind you, 7th grade, simplify does not mean to solve. Simplify means that we're just rewriting something in its simplest form, and that's it for us. We cannot solve it down to one number. We can just get it down to the answer there in blue. Last one here, it says Sally's grandmother gave her a gift card to Kohl's for her birthday. The gift card was not marked with a dollar amount, so we have no idea how much money is on Sally's gift card. Sally's sister Jenny was given a gift card worth $20 more than Sally's card. So, $20 more than Sally's. So whatever Sally's card is, that means Jenny's is $20 more than that. It says to write and simplify an expression to show how much money their gift cards are worth all together. So, Sally's card, we have no idea how much it's worth, so I'm going to use X as a variable to represent that amount. That's Sally. We know that we have to add Sally's gift card plus her sister's gift card, okay? So the sister's gift card, we don't know how much it's worth, but we do know that it's worth the same amount as Sally's card plus a bonus $20. So it's Sally's card, the X, plus a bonus $20. So there's our original expression. Sally plus her sister Jenny, X plus 20, the quantity of. And when we want to simplify this expression, we can just add our two x's together. There are like terms. X plus x is 2x. And our 20 is the constant. That's just going to be added at the end. Okay, we'll talk more about this kind of stuff tomorrow. That's as simplified as it can get because we do not have any like terms. All right, so tonight for homework, your assignment is to do 1B, find the terms, the like terms, the constants, the coefficients, and don't forget to simplify. You're going to do number 3, don't forget to simplify. You're going to do number 4, which is to write your own word problem, and then you're going to do your Google form. If you have any questions, let me know. We'll talk about them tomorrow. Don't forget, we're going to play a game, so you really want to